Hey guys, Mr. Gibson here. So today you guys are getting to do an introduction to something called Kami, Kami. So what Kami is it takes a PDF, something you would normally not be able to edit, and it lets you basically edit it. You can't change the text that's already in the PDF, but it lets you type, draw. There's a whole bunch of cool things you can do with it. We're going to use this a few times in chemistry, so I wanted to make sure that we had a lesson where you guys, the whole point is you just getting familiar with how to use it. So today we're going to do a small assignment where you guys are going to get to play around with Kami, and I'm going to walk you through it. Now it's in the world of chemistry. You guys are going to be doing some chemistry today, but we haven't even started our first unit yet. This is still just opening day's introduction stuff. So I don't expect you to already know any of this stuff, and that's why I'm going to walk you through it with you, and you'll see in here there's a safety net built in to make sure you guys are good to go, because like I said, today is just to get you used to Kami, not to test you on how much chemistry you know. So what you're going to do, go to Google Classroom, obviously, go to the chemistry one. You're going to need a periodic table. If you have a paper one, or if you want to Google one, you're welcome to do that. Probably the best one you have is if you go to your interactive notebook that you've set up. And for chemistry, it has this one right here. And so this would be really, really helpful for you to have pulled up, especially this one. Okay, so let's take a look at Kami now that we have that pulled up. I'm going to get you guys started and then just kind of leave you with it. So opening day is Kami introduction right here. You're going to click on that. It's got some instructions. Basically, it just tells you what Kami is and how to do the assignment. So what you're going to do is you're going to open this PDF right here. Now on your computers, it may automatically open up with Kami, or it may look like this. I've never opened it as a student, so I'm honestly not sure. But if it opens up and your screen looks like this, just click open with Kami right up here. It may take a second to load. It's pretty fast. All right, so here we have a PDF. Now, normally you can't do anything to a PDF, but with Kami, you could have this toolbar over here on the left. You can do all this stuff with your document now. So if you need to type something, you can make a text box. So let's go ahead and make sure your name is on there. And I didn't do that right. So click text box, click that, and you can make it as big as you want. You can change the font, you can change the color. Right now I've got it typed to red. If you wanted to make it blue, you can make it blue. It's really up to you. It doesn't matter. And you would just type your name. So my name is Mr. So there's that. You can put the date if you want to do block. We don't really have blocks. That's like synonymous for periods. Maybe the first period, second period. And then here's your assignment. It's going to have you draw what's called Lewis dot diagrams, Lewis dot structures, also called electron dot structures. So first, it has these elements. It's going to have you fill out this information about the elements and then draw the Lewis or electron dot structure. Again, this is really just so you get experience playing with Kami. If you're like, I don't know what this stuff is, that's totally okay right now. You're going to see here in a minute how to do it, but I've also built in a safety net for you if you're just totally confused. Okay, I don't ever want to overwhelm you or frustrate you this early. Okay, so I'm going to do this first one with you, carbon, just to show you kind of how it's done. So carbon is the element's name. The first bit of information it wants is the atomic number. Now, what in the world is the atomic number? Well, let's go to our periodic table. Okay. So you see the chemical symbol. Let's find carbon. It's right here. Okay. You see this number at the top, right above carbon, that's 6. And over here, nitrogen has 7, oxygen has 8. That's its atomic number. Now, the atomic number is the number of protons that an element has. And if it's neutral, which we'll talk about what that means later on, unit 1. Right now, they're all neutral. Just assume that. That means that the atomic number is also the number of electrons. So that helps us find a little bit of information there. So carbon, the first bit of info it wanted was its atomic number. It's atomic number 6. So let's go back to our Kami. I'm going to make a text box and just type the number 6. It's got an atomic number of 6. Okay, I've still got that in blue, which is cool. Now it wants the atomic mass. So let's go back to our periodic table. See this number down here that has a decimal? That is an element's atomic mass. Now you're going to learn what atomic mass actually is later on, but not today. You just need to know how to find it. So atomic number is at the top, atomic mass is at the bottom, and its atomic mass is 12.011. So I always like, unless you're doing like specific math, which you're not right now, let's just round that to the nearest whole number to make today really easy for us. So atomic mass, it was 12.011. Let's just round that to 12. Cool. Now, these are the 3 subatomic particles that make up an atom. So it wants to know how many protons, neutrons, and electrons are in an atom of carbon. Well, we already have all the information we need to find that out. The atomic number is the number of protons. So if your atomic number is 6, we've got 6 protons. If your atomic number is 18, you've got 18 protons. Okay, in this case it's 6, so protons is 6. Electrons, let's skip to there real fast. How many electrons does carbon have? Well, for right now, it's okay that you understand that the protons are always equal to the electrons. So if it has 6 protons, it's also got 6 electrons. That was easy. Now, neutrons. What in the world, how do we find the neutrons? Well, the atomic mass is actually all the protons and the neutrons, however many of each of those there are, added together. So if we've got 6 protons, we've got an atomic mass of 12, then what is the number of neutrons we have? How many neutrons added to 6 would give us an atomic mass of 12? Well, 6 plus 6 is 12, or 12 minus 6 is 6, however you want to look at it. So there are 6 neutrons. Protons plus neutrons is the atomic mass. That's the for sure way to always find the number of protons. Okay? So we've got atomic number of 6, mass number of 12, 6 protons, 6 neutrons, 6 electrons. Now, Lewis dot structure. How in the world do we draw that? It's actually very simple. First, what you want to do is type the symbol of the element, not the whole name. So if you look at the periodic table, carbon symbol is just the letter C. So we're just going to type a capital letter C. Okay, now I want to make that kind of big. Let's see if I can make the font a little bit bigger. You can play around with this too. Let's go to... That's not bad. You can make yours bigger if you want to. I'm just going to leave it there for time's sake. All right, so we've got our chemical symbol. Now, it says up here, it says determine the number of valence electrons. Well, what in the world is that? A valence electron is the number, it's not the total number of electrons necessarily, sometimes it is, but it's more specifically the electrons around the atom orbit, almost like how the planets orbit the sun, and you have shells of electrons. So the first ring of electrons can hold 2, the next one can hold 8, and so on and so forth. What it wants to know, what the valence electrons are, is how many electrons are on the outermost ring, or on the outermost level or shell. Okay? Because the reason it's important to know those, we'll get into later on, is just that those are the electrons that are doing all the chemical reactions. The inner shell electrons, or the other ones that aren't on the outside, really don't do much for chemical reactions. So it's important that we know how many are on the outer shell. So carbon has 6 total electrons, but that's not how many valence electrons it has. So let's go back to our periodic table. There are multiple different kinds of periodic tables. Some of them have numbers at the top, like 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. And you can always, when it has the letter A next to it, you can always trust that that number is how many valence electrons the elements in that column has. So for example, carbon, and it's not on this periodic table, and I kind of wish it was, but this periodic table has a trick to it too, would have 4A written above it. So it would have 4 valence electrons, or 4 electrons on its outer shell. Now this is actually doing you a little bit of a favor, and it tells you in the chemical symbol right here how many valence electrons, or how many electrons are in each shell. So for carbon, in the first shell, you can see right there it has 2 electrons. If you look how many are in the next shell, it has 4. So whatever that bottom number is going to be, that's how many valence electrons that element has. So in all these guys, helium has 2, neon has 8, argon has 8, krypton has 8. Over here, nitrogen has 5, phosphorus has 5, arsenic has 5. Carbon, in all of these guys, the last number on their electron list is 4. So we've got 4 valence electrons. So here's what we do with that information. We draw the chemical symbol, and then you're going to use your drawing tool. And you can make it whatever color you want to. Let's make them red, because red's kind of cool. You can change the stroke thickness. I like it at about a 6. You can make it a 10, 12, whatever you want to. You can also change the transparency of your drawing. Let's just make it all the way up. So what you do is you draw the number of dots around, you put a dot around the chemical symbol for however many valence electrons there are. So we saw on our periodic table that carbon has 4 valence electrons. So we're going to put 4 dots around carbon. So I'm going to put 1 on this side, 1 on the top, 1 on the right, 1 on the bottom, 1 on the left. Okay? Now, why didn't I just double them up and do 1, 2, 3, 4? Well, there's actually a rule. You can't do that. You can't double them up until there's 1 dot on all 4 sides. Okay. Now, you may be thinking, whoa, this is a lot of chemistry. You said I wasn't testing your chemistry knowledge yet. Don't worry. Like I said, this is just getting you used to using the drawing tool and the text box tool on Kami. So if you get stuck on one, like if you're doing hydrogen and you get to here and you're like, I have no idea what's going on, part of this document, and I want you to use this wisely. Don't necessarily, only use it if you have to. Only use it, let me just say that. Only use it if you have to, is the answer key, okay? I've got the answers in there for you. So if you drew carbon, like if I was like, man, I think I did it right, but I'm really not sure, just scroll down, take a look. Again, today is not quizzing you on chemistry. It's just getting you to use Kami. So I'm okay with you having that answer key today. All right. If you guys need any other help besides what I've given you already, absolutely feel free to email me and I'll do whatever I can to help you. All right. Thank you guys. See you later. Actually, hold on. Make sure before this is over that you have your name at the top. Then when you go back to the assignment, you're going to turn this document in for a completion, like just an effort grade, okay? You have the answer key, so they should all be right. So I can tell if you put in the effort, make sure everything was good to go, and that'll just be an easy grade for you guys. Okay, so don't forget to put your name on it and turn it in once you're finished. Now I will actually see you guys later.